Everybody, let us see electrical potential. In this topic, the work or energy per unit charges required to move the test charge from one point to another point in the electric field E is called a difference in electric potential. This electric potential always can have to give a electric field potential and potential drop or the electrostatic potential. According their representation, the amount of work needed to move a unit of charge from a reference point to a specific point inside the field. This figure shows the representation of electric field. It contains a charge particle and to move on infinitive. Work done by moving charge particle from infinity to other point is equal to the electric potential. This is called the displacement point charge Q in an electrostatic field E. Again, a negative line integral of electric field representation, the work done by the electric field on a unit positive charge it from one point to another point in the representation of electric field EF. So the equation representation or W base AB equal to integral dW equal to minus integral of E dot dl. Let Q naught be the test charge in place of the unit positive charges is the force act on the test charge due to the electric field. If the force is given by force equal to QE, Q represented charges, E represented electric field. It is radially outward and it tends to accelerate the test changes. Then this sign indicate against the force of both electric field in one point and another point. To prevent this acceleration, equal to the opposite force minus Q naught E has to be applied on the test charges. The total work done by the electric field on the test charges in moving it from A to B in the electric field representation WAB equal to integral of dW equal to minus integral of A to B E vector dot dI vector equal to Q into Q naught by 4 pi epsilon naught 1 by small r base B minus 1 by small r A. This is a definition of this electric field representation. This definition according their charges and field work of two component end. This electric potential difference, the work done in moving without any acceleration a unit positive charges from one point to the another point against the electrostatic force respective of the path followed. That respectation depends dW equal to F into dl. Already I told F having a opposite sign, so put minus F into dl. So replace of F value according their representation minus EQ into dl. So we can get VAB equal to minus integral A to B E into dl. It is denoted by VAB is known as the potential difference between points A and B. This is potential due to electric dipole. It contains two poles to over here their work done. An electric dipole consists of two point charges of equal magnitude but of opposite sign and separate by a small distance. That distance or Q and Q minus Q separated by a dl charges. It's being placed symmetrical about the point P at a distance r, where to find out the field and dipole can be written as V equal to 1 by 4 pi epsilon naught within the bracket Q by R1 minus Q by R2. So we can come out and placed out of LCM over here. Then we can write R2 minus R1 equal to 2 into d by 2 cos theta equal to d cos theta because the 2's are cancelled their mathematical representation. Therefore, we can get V equal to Q by 4 pi epsilon naught dr cos theta by r square. The quantity can have P equal to Q. D is called the dipole moment of the electric dipole. The expression is V equal to P vector dot AR cap by 4 pi epsilon naught r square. Next, we can move with boundary condition for electrostatic field. This is very common and important of this electrostatic field because it is rolling the entire engineering subject. So, we can give a more importance to this boundary conditions. This boundary condition says the tangential component of an electric field and normal component of an electric field can have to combine for done the specific work which is called boundary condition of electrostatic field. The electrostatic field meant by the electric dipole. An electric dipole is formed when 2 point charges equal magnitude and opposite position. Already I told the previous slides. So representation of that electric dipole, we have to summarize the equipotential of boundary conditions. That boundary conditions having polarization in dipole moment, that polarization consider a bound of two charges, that charges representation QA and QB. Next, we consider, so for existence of electric field in a homogeneous medium is considered if the field exists in a region consisting of two different media, the conditions that the field must satisfy at the interface separating the media are called boundary conditions. These conditions are helpful in determining the field on one side of the boundary if the field on the other side is known. Depending upon the types of material, the media are made of dielectric epsilon R1 and dielectric epsilon R2. Second is conductor and dielectric. Third is conductor and free space. So both three combination determine the boundary condition. The following two equations of electrostatic field are used. That equation relating the flux density vectors on two sides of the interface. Apply Gauss law to a small pillbox volume. The reference and refraction of DRE at a charge free dielectric interface. So conservative property and Gauss law always having electric field of E and distance and dipole of D are decomposed into two orthogonal components. That representation E vector equal to E base T plus E vector base N. This is electric field representation. Dipole representation are same, replace of E. So D equal to D base T plus D base N, where ET plus DT is tangential component of E and D. Then E base N and D base N, which is normal component of electric field and dipole. So it has more boundary condition component. Among those boundary condition component, let us see dielectric boundary conditions or do component dipole moment. That component or says dielectric boundary representation of tangential component E T1 and E 2T. Those two dipole or electric field component which is representation of tangential component to the boundary. Refer figure of this slide shown here. To find the tangential component, we will make use of the conservative and refraction of DRE. This representation always compare the electric field and dipole moment. That electric field says capacitance and dipole moment of tangential tan theta 1 by tan theta 2 equal to epsilon 1 by epsilon 2 equal to epsilon r1 by epsilon r2. Next we have to consider capacitance and capacitors. So both capacitance and capacitor conclusion across the boundary condition when a DC voltage source is connected between the conductor positive charges on one conductor and negative charges on the other conductor. The capacitance is given B is equal to Q by V. If geometry of the conductor and the permittivity of the medium, always representation C equal to epsilon A by D. The well known C is capacitance in farads, epsilon permittivity of dielectric, A area of plate overlap in square meters, D distance between plates in meters. Those capacitor and capacitance concludes the normal component of boundary condition according their representation of work done. Then energy stored and energy density always smooth surface of this capacitance, so is relatively a referable one.